In this video, we'll be learning how to identify the domain and range of a variety of different function representations. So before we can actually identify domain and range, we have to start by talking about what domain and range actually represent. So the domain, by definition, is the set of all possible input values of a function. So typically where you're going to find these are all of the x values that are used to create a function and the representation that you see. So we're going to be looking at x values specifically when dealing with the domain. Now on the flip side of that, the range is the set of all possible output values of a function. And these are typically all of the y values that are used to create that function. So they're all of the y values that result as a result of those x input values. So we're going to see lists of x values and y values, and those will help us determine our domain and range. And then in other situations, we're going to have to visually look at the representation and decide what are all of the x values that I need and what are all of the y values that I need. So let's take a look at this example here. So here we see a coordinate plane with a number of points plotted onto it. And we remember that domain is going to be dealing with our input values or our x values that we need to create this particular graph. And the range is going to be dealing with the output values or the y values of this particular graph. So since I know I'm going to be dealing with x and y values, I'm going to start by finding the coordinates of each of these points because I know the coordinates represent the input x values and the output y values. So if I start with each coordinate, here the first coordinate is x is -3 and y is 0. I can see -3, 0. Then from here, this coordinate here, x is -2 and y is -2 as well. For this coordinate here, I have x is 0, y is 2. For this coordinate here, I have x is 1, y is -2. And then for this coordinate here, I have x is 5, y is 2. So I can see here that I have coordinates with x and y coordinate parts for each point. Now, from here, remember, our domain represents all of those input x values. So since I just have a list of coordinates here, I'm just going to list out all of the x values by writing x equals and then finding all of the x values that I can see on my graph. So here I have x equals -3, then I have -2, here I have 0, 1, and 5. And then my range, I'm looking at the y values. So all of the y values that I need to make my graph include, I see -2. I see -2 again, so I'm not going to include that twice. I'm just going to list it once. I see that I need a y value of 0. And then I see that I need a y value of 2. And again, because that one appears twice, I'm not going to list it twice. So here, all I needed to do, since I had a list of plotted points, was list out all of my x values and then list out all of my y values. So now let's take a look at a mapping diagram. So here I can see my two circles, and I know that my input values are found in this first circle here. So these represent my x values, and my output values are in this second circle here where the arrows land, and that contains all of my y values. So for this one, all I need to do is list out my inputs and my outputs, which is really easy in a mapping diagram because they're already identified and listed out for me. So my domain here are all of my x values, which are all of my input values found in this circle. So I can list out x equals, and remember your x equals, and that's 3, -1, 2, and 4. And then my range, which is consisting of all of my y values or all of my output values, are all of those values found in that green circle. So I have y equals 2, 0, and -2. So now if we take a look at this third example here, your x values, remember, represent your input values. and your y values represent your output values. So again, in a representation like this, it's just visually displayed for us. Our input values, which go along with our domain, are our x values that we see in the table. So we have all of our input values listed out right here. So all we need to do is list out all of our x values. So we have x equals -3, -1, 0, and 1. Then our range consists of all of our output values, which are all of our y values, and those are found in this list right here. So if I list out y equals, I have 3, 1, 0, and then this 1 down here is repeated, so I don't need to write it a second time. But again, it's just listing out inputs and outputs. Now, where this starts to get a little bit tricky is when we have to find the domain and range of a graph with a line and an arrow. So you're going to notice something a little bit different on this particular graph. What you're going to notice is you have an endpoint down here saying that the line stops. And then you have an arrow, and really what this arrow communicates on a graph is that this continues on forever in this direction. And so representing these, unfortunately, isn't just a list of numbers. We actually have to denote an entire range of values, and we're going to have to use inequalities. So if you see an arrow on a graph with a line that's going forever in one direction, you should be able to note that somewhere you're probably going to have to use an inequality to represent your domain and your range. Now, while this might seem a little bit tricky, it's really not too bad. You just have to think about it a little bit more deeply. So remember that your domain represents all of the input values or all of the x values that you need to make points on your graph. So when I look at this graph, what I notice is that this endpoint pairs up with the point x equals -3. And what I notice is that the graph really doesn't exist on the left-hand side of x is -3. Do you see that? How I can pretty much scribble out this part of the graph, and you can still see my entire line, because the entire line is still over here, and it's pointing to the right, so it continues to the right. So I don't need any of the x values on that left-hand side. The x values that I need to create this particular graph start at -3. You can see that because that's where this endpoint is. They start at -3, and then the graph continues on to the right. So the graph continues to the right. So what happens is I need, all of these x values, all of these different numbers to create different points on the graph. I need this x value to create that point, and this one to create that point, and this one to create that point. And so what's happening is I need all of these x values that start at -3 and move to the right. Now, if you look carefully, this really represents a number line, right? So we have -3, -2, -1, 0, so on and so forth. I have a closed circle here, and then the graph, I'll do it right up above, is going to the right. And so because of that, the x values that I need start at -3 and then go to the right, which is where x is bigger than -3. So I can represent my domain by using my graph in the picture to say, well, the domain that I need, the x values that I need, they start at -3, and then they are all of the x values that are bigger than -3. And if I use all of those x values bigger than -3, I will be able to continue a graph to the right that will then ultimately create a graph that contains all of those points there. So that's how I can find my domain. I can visually see it by using the x number line on my graph. Now, what I'm going to do here is I'm going to erase all my scribbles, and I'm going to do this same thing for y. So again, I'm going to plot my point here. I'm going to show that my line fully extends on forever, noting that I'm going to need an inequality. And this time, I'm going to focus on the range. And remember, the range deals with the output values or the y values that I find on my particular graph. So If I look at my coordinate point, I can look over to the y-axis, and I can see that it pairs with -4. And so I know that the -4 is going to be an important part of my range. Then if I look here, what I notice about this -4 is that the graph, that line in blue, could pretty much exist even if the whole bottom part of this graph didn't exist, right? We don't need those y values on the graph. The y values that we need to create points on this graph are the y values that start at -4 and then work their way up. And so I need, this y value to make this point, and this y value to make this point, and, this y value to make this point, and so on and so forth. So I can see on this vertical number line that I have, and I know the vertical number line is a little bit weird, but it works the same, is I have -4, -3, -2, etc. And I need all of the y values that start at -4 and then go up and get bigger. So I can represent that in an inequality by saying, well, all of my y values, they start at -4, and then they have to be bigger than or equal to -4. So we can represent domain and range by using these inequalities as well when we have situations where we have an endpoint and an arrow that's implying that this graph continues on forever and ever and ever and ever in one direction. So let's take a look at another example here. So here we start with an endpoint. We can see where that endpoint is, and then we can see this graph continues on, and with the arrow continues on forever and ever and ever in one direction. So we need to find the domain and range of this particular function. So what I do with the endpoint for the domain is I start at the endpoint and I work my way down to the number line, and I notice that x equals 4 is a very important part of this endpoint. So I know that 4 is going to be a part of my domain. The biggest thing I have to figure out is, are my x values going to be bigger than 4? Or are my x values going to be smaller than 4? And to do that, I often look at the graph and say, what part of the graph do I not need? Well, I realize that I could cross off this entire part of the graph, right? And if I crossed off this entire part of this coordinate plane, I can still see my entire line. So what that's telling me is that my x values, they start at 4, and then they're working their way to the left. And when I look at the numbers to the left, which are the x values that are used to create that blue line, I notice that those numbers are smaller than 4. And as a result, my domain is going to be x is less than or equal to 4. Then if I repeat this process for the range, again, I start at my point here, my end point, and I work my way over, and I see that the important y value here is 5. So I have my y value, my range is going to deal with 5. And then I have to look again at my graph and decide where is the area that I don't need. Well, the area that I don't need is up above 5. Notice if I cross this off, the whole line in blue still appears. So I need all of the y values that start at 5 and then go downwards and go to smaller numbers. So as a result, my range is going to be y is less than or equal to 5. I need all of the y values that start at 5 and go down in order to create points all along this line in blue. And let's look at one additional example here. So here we have our endpoint, and then our line has an arrow going this way, which implies that it continues on forever in that direction. We're going to start by finding our input values or our domain values. So we have our input values that deal with x. So we're going to start with our domain. We look here and we take our graph and we go down to the x-axis, and we notice that -3 on the x-axis pairs with that endpoint. So here, I know that the -3 is going to be important, so I know that x is being compared to -3 in some way. I just have to decide, are all of the x values that I need to create this graph going to be smaller than -3 or larger than -3? So again, I'm going to look at my graph and I notice I don't need any of the points on this side of -3. I can cross off all of these x value parts on the coordinate plane, and the whole blue line still appears. So I know that I need all of the x values that start at -3 and then move to the right, which are the bigger x values. So my domain here is going to be x is greater than or equal to -3. And that communicates that I need all of the x values that start at -3 and are then larger than -3 in order to create points all along this line. Then if I flip gears here and look at my range, I look at the y-axis here, pairs with 1. So I know that 1 is going to be an important part of my range, and I really have to decide, am I going to start at 1 and go up, or start at 1 and go down? And what I look at here is, again, I look at what part of the graph do I not need. Well, I don't need any of these y values up here to create points on my graph. Notice if I cross them all off, the line in blue still appears. I can still see it. So as a result, I know I need all of the y values that start at 1 and go down. I need all of these y values to create various points on my graph or on my line. So I need all of the y values that start at 1 and go down. So my range can be represented by y is less than or equal to 1.